Okay, now let's look at, we have this, we have used a toString method. Have you used the toString method in the rectangle class? We were looking at string conversion, which would happen in the rectangle class, right? Fine. And for that, what we did? Okay, I think I'll just open the rectangle class again and see what we had done that time. Okay. Yeah. Fine. Let's look at the rectangle class again. So here, we have done something like this. This is constructor. We have the methods length, width, area, set dimensions method, and of course we have this method public string toString. Okay, fine. Now I'm putting an annotation here called @override. What do you think? Is it an overriding method or is it a new method? Okay, if it compiles, then what would it mean? It's a method from superclass. Okay, superclass for rectangle. Okay, let's come to that. Sorry. Okay, let's compile. Fine. It's not giving an error. Right? So what does it mean? This is a method which is from a superclass. So for rectangle, what is the superclass of rectangle? Right? We never mentioned the superclass. We didn't say extends. So when we don't put a extends while defining a class, what is the superclass? Superclass is the object class. Same way, it's not only for the super class of rectangle, it's also for account. Yeah, we didn't mention the superclass for account. Yeah. So when we are not mentioning a superclass, the superclass is account. We could see that in account in rectangle, when we are saying toString method, we are defining a toString method and saying, oh, it's an overriding method and it is working. And it means this is a method from which class? Object class. Right? So what is the purpose of toString? Have you seen what is the purpose served by toString? What happened because of toString? Right? And it was used for defining the string conversion. How string conversion should be done. And that's what is being happening with the help of toString method. Right? And we could do that, right? We could decide how string conversion. So when we do a string concatenation, string conversion happens. Okay, fine. So how is a string conversion done for objects? Okay. Okay. Now one more point here is the point to see here is that yes, there is a string conversion which was available by default. There was some kind of a string conversion. If I didn't have the toString method, there was a particular behavior. Okay, let's check. Okay, I think we can try running the code for test rectangle. Test. Okay, so are we seeing anywhere toString? Yeah, R1 is rectangle colon, and so after R1 is rectangle colon 7 by 5, right? That's a string conversion, right? What we can do here is we can go back and override the fine. Let's comment out the string conversion, right? And it should still be working. Okay, let's check this. Okay, we have compiled the rectangle, and let's run the code for test rectangle. What has changed? R1 is, and then gives the name of the class at the rate. So there it is there. It is doing a string conversion, but the string conversion is not meaningful for us. It has a string conversion available. So there was a string conversion available by inheriting the toString method of object class. So object class has certain methods with some purpose which has been used, fine, because this is a class which is super class for everyone, fine. It is going to affect all the other all subclasses, okay, anything whatever is happening here, right? So we need to know what all are the methods, just like a string conversion is being defined here, what all methods are there available in the object class. Okay, fine. So let's see what all methods are available in the object class with their purpose. Okay, fine. So, yeah. So what are the methods of the object class? I can first list them out. Okay, fine. Okay, so let's see the list of methods. And then we'll look at them one by one. Okay, so first method, maybe there's a method public method returns int, name of the method is hash code. Okay, next method we have a method which is a which we already know of, and we have the method called string toString. Another method which I have talked of when we were looking at the operators, right? Instead of using the double equal to, we have a method to return boolean. Name of the method is equals, parameter is a object. So you can compare an object with another object for equality. Okay, see, whatever is true for any object in Java is what is available through object class. So object class provides us the minimum operations which we can use on any object, including arrays. Okay, arrays are also objects. Okay, fine. Then we have another method, public method. This method is okay. We have this method which is final. Okay, method's return type is class. Name of the method is getClass. Yeah, I did mention about the class called class sometime, if you recollect. So we have a method to return for a given object. What is its class object? Recollect, when is this class object getting created? When the class is loaded. Okay, whenever a class is loaded, a class object for that type would be created. Okay, when you create an object, right, it is by looking at this class definition that it would create a new object. So the object knows what is the type. So every object is of a particular type. Type is represented by the class. Okay, we'll see that further. Okay, fine. Then okay, then there are a couple of methods. Okay, we have a protected method, returns object, name of the method is clone. Okay, of course there is something more here, throws. Okay, that throws indicates the kind of error which you may get in case you use this method. Sometimes, yes, this is what you may, this is an error which can be expected, right, if you use this method. So this method may not work all the time. Okay, we'll see when it can work and when it cannot work. Okay, but object class has this method. Okay, there's another protected method, but this is a deprecated method in the sense it's discouraged to use this method. Okay, there's also a method called finalize. Okay, fine. And then I'll write, this is 6 methods. There are 5 more methods. Okay, but we may be discussing them at the time when we discuss the multi-threading. These are related to multi-threading. So I'm just listing them here. Okay, so we have this public and final, return type void for all of these methods. There's a method called wait, and it has parameters of type no parameter, that's one. We have public, final, void, wait method. Sorry, this also has a throws here, throws. Okay, I'll just copy this. This method is overloaded, so you can have a parameter of type long, timeout in milliseconds. Okay, and another overload of this is where we have one more additional parameter. Okay, okay, so nanos. Okay, timeout is specified. In this case, there is a wait with a timeout. The value of timeout is specified in milliseconds, and in this case it says, okay, we are giving the value of timeout in milliseconds plus so many nanoseconds, so more precision. That's the only difference. Okay, fine. And we have the public and final method, return type void. Name of the method is notify. And okay, this also, yeah, we have a method called notify all. Yeah, so these are the 11 methods available in the object class. Okay, so total of 11 methods available in the object class. So any object, these are the methods you can invoke on them. Okay, of course, these methods which are related to multi-threading, they have a few requirements before you can use them. Okay, you can't be just calling them. If you try calling them, they may give an error, and they may normally be throwing an exception called the illegal state exception. So there are some requirements before someone can invoke those 5 methods. Okay. Okay, but yeah, so let's concentrate on the first 6 methods here. Also to note one thing, this method is final. What does it mean? Yeah, what does it mean? You won't be overriding. So when you define a class, see, what did we do? We did a @ override for the toString. Right? So those methods which are not final, understand, they are there meant for being overridden. They may be overridden, fine, you may, fine, and maybe it's good idea most of the time, if required, try to override them. And especially the first 3 of them, the first 3 methods listed here are the ones which are most commonly going to be overridden. Okay, fine. The other 2 methods here, yeah, these the last one anyway, now they have said, okay, stop using this. Okay, finalize, it had a purpose, but yes, now they have said, okay, we don't use some other mechanism, but not this. This is more related to a garbage collection. Okay, when an object is going to be garbage collected, right, it's a garbage collector which can decide which object can be is not usable and would like to deallocate the object. So before it deallocates or destroys that space allocated for this object, it would invoke this method. So the idea was that yes, if you override this method, fine, you override the method to do something which you would like to be done by the garbage collector before it does a deallocation. So if the deallocation happens just before that, something is to be done, okay, then override this. You specify what should be done before deallocation. This method is not for deallocation. This method does not do a deallocation. So don't take this as a destructor. Okay, if you are having the concept of constructor and destructor from C++, okay, it's not the destructor in that sense. It's a method which will be called by the one who is going to use the is going to destroy the object. It's not a destructor. Okay, when calling this method will not destroy the object. It will not deallocate the object. Okay, fine. So fine. So 5 of these methods, yes, you may be overriding them. Fine. And what's the purpose of overriding each of them? So let's start with the first one. Yeah, second one we have already seen. What is it for? What's the purpose of the overriding a toString method? To string conversion. So you would like to define your own string, take control of the string conversion. We're not familiar, we don't find that good, the string conversion which is done by the object. What is it? What is the object class doing for us? It's creating the class name @ and giving some hexadecimal value. You know what is that hexadecimal value? It's using the hash code method. It's using the hash code method, and whatever value it gets, it's converting into hexadecimal. Okay, so string conversion is nothing but, yes, it's linked to the hash code. Okay, it is displaying us the hash code, the default one. Hash code has a different purpose altogether. Okay, fine, but yeah, okay, but there is some relation between equals. What's the purpose of equals method? Yeah, right. Equality, it defines the equality. When do we consider 2 objects to be equal? Fine. See, that double equal to is about checking if it's the same object. It's not about same object, but whether the 2 objects can be considered to be equal. I have one rectangle of 7 by 5. I have got a separate object of rectangle which is also a 7 by 5. Should they be considered equal or should they be considered as not equal? They are 2 distinct objects. If I use the double equal to, it's going to say they're not equal. The double equal to is saying, oh, it's not same. So equality is about not same. Okay. So this one is about, you would like to know whether the two objects are equal. The one who defines a class has to decide the equality rule. You are creating your data type. When you are defining a class, it's a data type. So for your data type, you have to take the decision. So this is used for equality. This is used for string conversion. Okay, fine. Now, hash code is used by some data structures, okay, which use hashing. Fine. There is a data structure called hash table. Okay. Fine. So when you want to organize your objects in a hash table, there is something called hash computation. So it says, fine, whatever hash, if someone needs a hash value, hash computation to be done for this object, this is the method which will give the value. Right? The hash computation has to be done with the help of this method. Okay. So what is a hash code? It is simply some integer value associated with this object. Okay. Right? Hash code is nothing but an integer value associated with the object. And what about the method clone? Clone method? Yeah. Create a copy. Create a new object, which is a copy of this object. But one thing here, it says there is an error possible if someone tries a clone. What is that error? Clone not supported. By default, for all the classes, okay, it will say clone not supported. Fine. It will just say it's clone is not supported. Okay. Fine. Fine. This we can take up later once we know about interfaces, because there's a requirement of some interfaces. Okay. And finalize used by garbage collector. Okay. Currently used by garbage collector, but they have said, fine, Oracle is saying that yes, they would like you to stop using this method. Find some other ways of finalization. Okay. Okay, so yeah, so let's look at this one by one. Yeah, so now, yeah, there is one relation. Yeah, so there is a relation between equals and hash code. Okay. Also about equality, equals. So okay, toString is fine. Yeah, one important one is this you cannot override, but it's an important method, get class method. When get class is important, why? It lets us know about the type. Okay, it will let us know about the type. Okay, fine. I think what we will do is here, we will go through these methods and try to apply them with the rectangle class, and then use it with the subclass also. Let's see the effects in the subclass. Fine. We have done a subclassing for rectangle called a cuboid, which is under the inheritance package. Okay, so yeah, we'll still use that, right? The one which is using inheritance. Okay, cuboid with inheritance, we'll be using that. Okay, but yes, we have this. Okay, fine. So what is hash code? Okay, it's nothing but some int value associated with the object. Okay, fine, and you are free to override. Okay, you're free to override the hash code method, and because we have a relationship between hash code and equals, okay, there is some kind of a relationship. Okay, the rule will become that yes, whenever we override equals, we'll also override the hash code. So they go both together. Equals and hash code have to be consistent with each other. Okay, we'll see how they need to be consistent. We'll see that when we look at it in our example for rectangle class, and then subsequently for the cuboid class, which is a subclass of rectangle. Okay, and equals method, toString method. String conversion, yes, broadly we know it as a string conversion. How we would like to do the string conversion is also one thing. Okay, but for that, yeah, we may like to first understand about this particular method, get class. Yeah. So what is get class returning? Okay. Okay. What is this class called? Class. Okay. Okay. Now I'll make a few statements here. Okay. There is a class object. Okay. So we have an object of the type class for every data type in Java. Okay. What are the types we have been using so far? Oh, we have used the types called int, and we have used the type, the primitive types. Yeah, we know the primitive types. Okay, we know the array types. We know the type called rectangle, cuboid, account, current account. Whatever we have defined, all the classes which we have defined. So we have so many. We have interfaces, enum, annotation. They are all nothing but they are data types, and there is a class object for each of them. Okay, for any data type. Okay, int. Okay, okay. So for any data type, let's say any data type, just say D. Okay, if D is a data type, okay, then we can get the class object by using, okay, what we have to do is we'll say D dot class. Of course, the class here is the keyword. Class we understand is a keyword used for defining a class. But yes, I can just say, for example, okay, int dot class. Yeah, you can write like that also. Okay, so it's like this. This is a valid thing. Class C equals int dot class. This is valid. Okay, fine. So for any data type, yes, you can get the class object by using the, just put dot class after it. Fine. And another example I'll say, okay, I'm just giving, so int array dot class. That's also a class object for this. So you can say class C1 equals int array dot class. Just put a suffix of dot class. with any data type, you get the class object for that type. Right? So what does a class object have? It has information about the type. Right? First information. See, this is simply an object, right? You can say, oh, this object is for, what is the name of that type? And you want to know the name. Given a class object, you would like to know, oh, this is a class object. It's a data type. It represents a data type. But for what's the name of that type? Okay. Now, is it a class type? Is it a class? Is it a enum? Is it a interface? Is it an annotation? Is it an interface file? Or is it a primitive type? Such questions will arise. And that's what it answers. The methods in the class are just to get information about a type. It represents a type, and you can get all kind of information about the type. Okay, I'm just giving you a quick look at it. Okay, and I can just say class C equals int dot class. Okay, yeah, it has created a, so there's a class object of type class, fine. Okay, and we can just say C dot get name. Get name is a method in the class. C dot is it a primitive type? Oh yes, it's a primitive type. Okay, fine. Let's also create another one. C1 equals or simply let me try, because it should be able to resolve this string dot class. Okay, but that class is not string, it has resolved it to java.lang.string, right? And okay, let's try the same thing. C1 dot get name. Okay, and so get name is a method of class. We also have another method called C1 dot get simple name, and simple name is string. C1 dot, oh, you want to say is primitive? It's not primitive. Okay, fine. See, this is just to introduce you to what is a class. The idea that this is giving you information about a type. Okay, fine. So yes, we'll continue tomorrow. Fine, but fine. Understand this just to give an idea about this, and this could be quite useful even when we use the toString method, even when we use the equals method. When we are overriding that, maybe we'll need some information which we may use from here. Fine, in our string conversion. See, the object class, what is the default string conversion in the object class? Okay, I'll tell you what it is basically. Okay, how the string conversion is done for the object class. I have a string, let's say I have got string, okay, okay, s dot, fine, we can say, okay, for string, yes, it's actually doing a string conversion properly. It has overridden the toString method, but for something else, I couldn't have done it unless I had used the J shell with the class path. Anyway, fine, we'll continue tomorrow. We'll see that tomorrow. So, fine. So tomorrow, initially we'll look at the class and get some feel of the class, and then we'll look into the other methods of the object class, and we'll try to override them, fine, in the rectangle class, cuboid class, and wherever required again in the account class. Okay, fine. For account class, I'll give it to you as an exercise initially. Okay, fine, overriding these methods. So one next exercise will be related to overriding methods of the object class. Right? Especially those three methods. We would like to override those three methods. Okay, fine. So any questions? Yeah.